Assalamu alaikum. This is Saadat Nisar with course E Commerce. If you recall, we had discussed the working of the network interface card, and I told you that a network interface card, it contains a 12 hexadecimal character address on it. We call that media access control address or MAC address. This MAC address is the physical or the hardware address of a machine on the internet. Now, I told you that underneath these 12 hexadecimal characters, there is a unique pattern of 48 bits. So we can say that there are 2 raised to power 48 different combinations of zeros and ones possible in case of a MAC address. We can infer therefrom that there are 2 raised to power 48 different unique MAC addresses possible, and we can say that there are 2 raised to power 48 different NICs possible having different MAC addresses on them. Next networking devices that we shall talk about are hubs and repeaters. Hubs basically are used to connect different computer machines on a LAN. We can say that hubs are central connection point using which different computer machines, they can be assembled with each other. Hubs, they have ports on their backside, and using these ports then connections can be made. Hubs come in different shapes, in different sizes. They organize cables, they relay data signals to different computer machines sitting on the LAN. Then repeaters. Repeaters basically are used to amplify electric signals. So after covering some distance, the electric signals, the electric pulses, they tend to get weakened. And repeaters are precisely used to amplify or regenerate the electric signals. Both hubs and repeaters, they do not have any role in the control of data traffic or the regulation of data traffic. They are not intelligent devices as such. Before we start our discussion on bridges and switches, which are again 2 very popular LAN devices whose role is to conserve or enhance bandwidth of the LAN, it would be useful if we discuss the terms LAN topology, and we also have an overview as to what are different networking approaches for constituting a LAN. Topology means the physical layout of a LAN. So you have to, first of all, as a network designer or administrator, you have to first of all visualize that how many machines are going to be combined to constitute your LAN, and in what physical shape they are to be assembled with each other. Mainly there are 3 different topologies which have been conceived. One is the bus topology, in that there is a single trunk line, and on various intervals on that trunk line, the computer machines are attached to constitute a LAN. Then comes the star topology. As you can see on the slide before you, in star topology, there is a hub using which different computer machines are attached with each other. Hub plays the role of a central connection point here, and in the formation of a star, then computers are laid out, they are assembled to constitute a LAN. The third topology is the ring topology. In ring topology, the computers are attached to each other in the formation of a ring, a physical circle, as you can see in the slide before you. Then what are the various networking approaches? There are mainly 2 network approaches. One is server-based networking and the other is peer-to-peer networking. In server-based networking, there would be at least a single server machine, a single central machine which would be serving certain resources to the user sitting on the LAN. So you are familiar with the examples, file server, print server. These are the examples of server-based networking, where there is a central file server or a print server, and the user sitting on that LAN, they send requests to the print server or the file server for certain resources, for sharing of these resources. On the other hand, in peer-to-peer networking, a computer machine can both act as a client as well as a server machine. Peer-to-peer refers to computer machines having equal capabilities. So in a peer-to-peer, which is a small type of network, in a peer-to-peer network, a computer machine may be acting as a client machine. It may be sending requests to a file server, requesting certain files to be supplied, and at the same time that particular machine may also be acting as a server, allowing certain other machines to send their print requests, and in that way it acts as a print server. So this is the example of peer-to-peer type of networking. Now, the devices, the popular devices on the LAN which are used to conserve bandwidth, these are the intelligent devices. They are bridges and switches. Bridges and switches both are combination of hardware and software. They have their own operating system. Their working, although, is slightly different from each other. In case of bridge, the larger network, the LAN, is chopped or divided into small networks or small network segments. And then all these different segments, they are connected with each other with the help of the bridge. Both bridges and switches, they increase the bandwidth of the LAN. Bandwidth means that the number of bits that can be transmitted across the network in a given time. Bandwidth is measured in terms of bits per second or million bits per second. Basically, it determines the fastness or the speed of the network. How does a bridge increase the bandwidth? Basically, the bridge has the software capabilities whereby it can read the MAC addresses of the data packets that arrive at a bridge. The bridge has stored a table in it, and in this table there is the information of the MAC addresses of all the computer machines which are sitting on different segments of the LAN. When a data packet arrives at the bridge reads the MAC address on that data packet and then matches it with its table, with the list of MAC addresses contained in its table. And based upon that matching, then it forwards the data packet to the MAC address whose information was printed on the data packet. So in this way, the bridge would only allow the transmission of data packets to those segments to which these packets belong. It would not allow the data packets to travel on a segment to which these packets have no nexus, where they do not belong to that segment. As is apparent before you in the slide, you can see a data packet reaches the bridge. The bridge has divided the larger network into three segments, S1, S2 and S3. These three segments, they are connected to each other with the help of bridge. The bridge matches the MAC address on the data packet with its list of MAC addresses, and then say it finds out that this particular packet belongs to a computer machine sitting on segment 3. Therefore, it would deliver that packet to segment 3. Therefore, it would not allow the packets belonging to segment 1 and segment 2 to go to segment 3, and segment 3 therefore would not have any unnecessary rush of data packets. Segment 3 would only receive those data packets which belong to computer machines on that segment. This is how we say that a bridge conserves or enhances the bandwidth of the network. Switches do the same job of enhancement of bandwidth as do the bridges, but in a slightly different way. In case of switches, we do not divide or chop the larger network into physical segments. Rather, we do this division logically or virtually. And each such division is called a virtual LAN or VLAN. So therefore, similar type of users, they can constitute a particular VLAN or virtual LAN, and then data packets are only delivered to that VLAN to which these packets belong, and unnecessary packets, irrelevant packets, do not arrive at such VLAN. And thereby we say that bandwidth has increased. I'll give you an example. Say there is a building and there is a network established in that building. There are a few engineers who are sitting on the computer machines on the first floor. So there are 3 engineers sitting on the 3rd floor, 5 engineers sitting on the 5th floor of that building, and we want to convert these engineers into a group, a communication group. So by specifying the MAC addresses of all computer machines which relate to these engineer users, we specify these MAC addresses to the switch, and then it constitutes a communication group, the engineers group. Similarly, the switch can also form a group of accounts people, a group of marketing people, etc. Different communication groups, therefore, can be established in spite of the fact that people constituting this group, they have no physical proximity. They are not sitting near to each other. They are spread over the building. In spite of that, the switch can work effectively, and it can constitute, it can provide these different communication groups. The functioning of the switch otherwise is quite similar to the bridge. Again, the data packets, when arrive at a switch, the switch would read the MAC address on that data packet and then would try to match that MAC address with the list of MAC addresses already stored in it. From there, it finds out that this particular message, it belongs to this communication group, say engineer group. So the switch would then forward these data packets to the engineer group alone, and the engineer group, it would not receive data packets that belong to other groups. It would only receive the data packets which belong to its group. In this way, we say that bandwidth, the speed of the network, increases with the help of switches. When you are going to design your network, you have your space considerations before you. So therefore, you decide whether you want to employ a bridge or you want to use a switch for your network. For example, in case your network is confined to a particular floor only, then it is more feasible to use a bridge for bandwidth enhancement. On the other hand, if your network is spread over the building at its different floors, then it is more favorable option that you use a switch as compared to a bridge. The next networking device, which is a very important device on the internet, is a router. Routers are used on the internet. They are a global device, therefore. So you can say that there are thousands of routers which are placed on the internet, and they are performing their job of effectively and efficiently sending data packets from one point on the internet, from one machine on the internet to a remote machine on the internet on the other side. Router is basically a computer machine. It is a combination of hardware and a special software. It has got its own operating system. The routers divide the internet into subnets or smaller networks on the basis of IP addressing scheme. So therefore, there are various different subnets, many subnets. Each subnet would have its router, and with the help of these routers, these subnets would be connected with each other over the internet. The router which allows the entry or exit of data packets into the or out of the subnet is called the default gateway. The default gateway IP address is configured at the same time when the other IP settings are configured. So therefore, when DHCP or Dynamic Host Configuration Protocol server, I mentioned that in our previous lecture, it supplies dynamically the IP address given to a client machine. So when that DHCP server provides the IP address, at the same time the default gateway IP address is also configured or provided to the client machine. When the data packets, they arrive at a router, the router has got a table contained in it. I told you there is a routing information protocol. This is a protocol using which routers can talk to their neighboring routers. And with the help of that, they can create their table. This table is about the network addresses. So in their table, they have got the information of all the network addresses available on the internet. When the data packets, they arrive at a router, the router would consult its routing table, and from there it would try to find out, it would make a decision as to what is the shortest possible path through which these packets can be delivered to the receiving machine. And this is how we say that router is a very smart device, smarter than bridges and switches. It is a decision-making device. It decides about the shortest possible path through which the packets are to be delivered. I show you a slide. This would illustrate the working of a router. As I mentioned, the routers, they connect various subnets to each other. So you can see there is a class B network 140.57, and an ISP may have arranged this class B network. There is a client machine sitting on this network. We say this is a machine A. This machine A, client machine, wants to send certain information, certain data to a machine, to a server machine, say at network number 100, A-type network, and the machine sitting on that A-type network, I have termed it as machine B. R1 is the router, is the default gateway attached to network number 140.57, and R2 is the router attached to network number 100, the receiving network. There are other routers, you can see R3, R4, R5, R6, all these different routers, they are connected to their respective subnets, and in this way a web is formed. Now, when the data packets from client machine A, they arrive at its default gateway R1, R1 first of all consults its routing table. And from its routing table, it finds out what is the shortest possible path through which I can send these data packets to network number 100, to machine B sitting on that network number 100. It finds out through its routing table that the shortest possible path is that it just needs to have one hop or one jump. If it sends these data packets to router R2, then R2 is in fact the default gateway of network number 100, and therefore these packets would safely be delivered to the machine B sitting on network number 100. In this simple example, there is just one hop. The shortest possible path is that R1 sends these packets to R2, and from there they would automatically then be delivered to machine B. On the other hand, assume if there is any blockade between the path of R1 and R2, or assuming that R2 is switched off, it is not in the on condition, then in that case, the router R1 would look for any alternative path. It would try to find out through its table that what are other alternatives or possible options or possible paths through which these packets can be delivered to machine B. From its table, then, it finds out that another optimal alternative shortest path is that it sends these packets to router R3, which is below R1. And then R3 would send these packets to R4. R4 then would deliver or route these packets to R2, and from R2 then they would be handed over or forwarded to the machine B. In this alternative route, now there are 3 hops, from R1 to R3, then R3 to R4, then from R4 to R2. This is the alternative shortest possible path which a router can figure out, and then it would use this alternative path to deliver the packets to machine B. This is how we say that a router is a very efficient device, and it can deliver the data packets using the shortest possible path, and therefore it conserves or it enhances the bandwidth over the internet. Our next endeavor is to see that what are the various connectivity media possible. Connectivity media, what are those options using which we can connect computer machines on a network? First of all, the more basic type is the cable options, the copper cables. In copper cables, there are further 2 categories. One is coaxial type and the other is twisted pair type. In coaxial, there is just one main copper cable which is used to connect computer machines on the network, and there are certain specifications of coaxial type. One is thicknet, the other is thinnet. Thicknet is that subtype within coaxial which is heavy gauge, which is inflexible, slightly more expensive. On the other hand, thinnet is that subcategory which is cheap, which is more flexible, more easy to install. In case of twisted pair, there are further 2 subtypes. One is the unshielded twisted pair and the other is shielded twisted pair. The unshielded twisted pair is a more common type, less expensive, more flexible and more easy to use. On the other hand, the shielded twisted type is relatively more expensive. There is a further foil wrapping which is used to protect that cable. It depends upon our different considerations, what type of cable are we going to use for our network. Then within the cable options come the fiber optic. You may have heard about fiber optics. Basically, these are those very expensive special type of cables which have been laid down under the sea, and they carry the data from one point to the other very speedily, in fact with the speed of light. These special cables, they are made up of glass or plastic filaments, and on different intervals there are special lasers or light emitting diodes which are placed on these fiber optics. These diodes or lasers, they emit packets of light, and then our data packets sitting on these packets of light travel with the speed of light over the fiber optic. We can say, therefore, fiber optic is a very, very speedy mechanism of transportation of data. They are relatively difficult to install, of course. We have to keep them straight. Moreover, there is a difficulty for hackers to steal the data of the fiber optics. This stealing of data otherwise is called tapping. So stealing of data is much, much more difficult for hackers over fiber optic. Then the other cable options are telephone lines and existing electrical wires. How do we use telephone lines for connecting computer machines? A very common example is that when we use a telephone modem. What does a modem do for us? A modem, in fact, connects us to the ISP whose client we are, and it converts the electrical signals into sound signals, and then these sound waves, they travel along the telephone lines and they are then picked up by the ISP modem, which converts them or demodulates them. It converts them back to electric pulses, and then from there, with the help of the routers, then these data packets, they travel over the internet to a destination point. Similarly, our existing electrical cables or wires, they can also be used for connectivity purposes. There is no problem about that. Then there are wireless options for us. As regards the connectivity, there are certain options which do not use wires for connecting computers. At the top of wireless connectivity, we have radio connectivity. So radio connectivity means that with the help of, by adjusting frequencies of radio waves, we can transmit data from one computer to the other. In other words, we can connect computers with the help of these radio waves at specific frequencies with each other. There are two very common, very popular technologies in this regard. One is Wi-Fi. Wi-Fi technology using the radio waves is a concept which has been very popular in the past. In this technology, there is basically a wireless access point device, a central device called WAP. And each computer machine on the network, they have wireless interface cards. With the help of their wireless interface cards, the user machines, they get in contact with this WAP or wireless access point, and thereby the connectivity is established between the computer machines. And there is no wire used as such in this concept. Then there is another very popular technology, Bluetooth technology. This is quite in vogue these days. Again, in Bluetooth technology, there is a point-to-point connection between user machines on the network. Remember that both in Wi-Fi and Bluetooth, the connectivity range is not much. Mostly it is up to 10 meters or so. Within this range, we can establish wireless connections between various computer machines. Then another type of connectivity is through infrared waves. Infrared waves, they are very high frequency waves. They are slightly short of electromagnetic waves in frequency, and they also are used for arranging a small range connectivity between computer machines. Another type of wireless connectivity is through satellites. In case of satellite connectivity, there is a device there is an antenna, satellite receiving dish antenna, which receives the microwaves from the satellite, and using these microwaves, then the connectivity is established. So wherever we want to establish connections between remote places, we can use satellites. Now, for the internet, as regards connectivity on different areas, different patches, we are using fiber optic. So fiber optic is being used for connectivity purposes, and thereafter the data is further picked up maybe by satellite, and then further connectivity is then established through satellites. From satellites, then maybe infrared connectivity, and then from there maybe radio connectivity. We can't say that on the internet only one single media is being used for connectivity purposes. Rather, there is a combination of different connectivity media which are being employed to establish connections on the internet. Then I want to talk about two very important protocols that have relationship with the working of the routers. And these are ARP or Address Resolution Protocol, and the other RARP or Reverse Address Resolution Protocol. Remember, I told you there are two addresses, IP address and MAC address. These two addresses are different. IP addresses are those 4 decimal numbered addresses separated by dots, which are assigned to a user for a session to identify the user machine, and MAC address is the one printed on the network card. This is a hexadecimal address. With the help of Address Resolution Protocol, each computer machine on the internet, it prepares a list of its IP address corresponding its MAC address. So each computer machine would prepare a list that this is its IP address allocated now, and this is its particular MAC address. With the help of Reverse Address Resolution Protocol, RARP, this computer machine on the network would not keep this information or list within itself. Rather, it would transmit this information, forward this information, this list, to a centralized device called network server. In other words, we can say that network server contains the IP and MAC address list corresponding to each machine on that network. As you can see in the slide before you, when the data packets, they arrive at the destination router, the destination router first of all sees the IP address on that data packet and inquires the network server placed on the network that what is its corresponding MAC address. Please let me know that. This is the step number 2 before you. The MAC address is inquired to the network server. The network server checks its list, finds the MAC address, and in step number 3, as you can see, it forwards the MAC to the destination router. The router then inserts that MAC address on the data packet and then delivers this MAC address precisely to that machine, to that web server for which this data packet had been sent. You can see this is the step number 4 before you. The question is, why do we use MAC addresses? The answer is that because if we rely upon IP addresses, then it would not be very trustworthy that the packets would actually be delivered to the receiving end. So therefore, we can say that the routing takes place with the help of the IP addresses. But at the destination point, we need to have the MAC address. And that MAC address is inserted by the router of the destination, the default gateway at the destination, and then with the help of that MAC address, the data packets are delivered to the exact destination or the computer machine. We can infer therefrom that a data packet needs both IP and MAC addresses to be delivered to the destination. Our next topic is the role of ISPs for data transmission on the internet. The ISPs, internet service providers, they have the key role for connectivity purposes on the internet. What are the different things, the different services that ISPs can provide for us? First of all, ISPs provide internet connections, which means that you pay to the ISPs and then you get the internet connection. Using that internet connection, then you may establish a virtual private network. We have some discussion on that in some previous lecture, which means that using internet infrastructure, using connection from the ISP, your smaller network becomes a part of your head office network with the help of VPN protocols. Then web hosting service is provided by the ISPs, which means that whenever we create our web pages, we always can take these web pages, their code, to the ISP, and we can store this code in the ISP's hosted web server. The ISPs can assign us a domain name. Using our domain name or URL, then our web pages can be accessed through this web server established by the ISPs. I may point out here that instead of using ISP's web server, we can also arrange our own web servers. So by installing our own web servers, we can save our code, our web page code in our web servers, and then from there the users can access our website. Web browsing is another service which is provided by the ISPs. So surfing on the internet, locating or accessing different websites is possible if we have services from the ISPs. Then ISPs can also provide email services, which means that ISPs can arrange an email server, a machine called email server, wherein there would be prepared our account. We'll have our mailbox there, and using that account, that email address, we can then access that email server placed by the ISPs, and we can then send email messages on the internet. We can receive messages through our mailbox over the internet in this fashion. Another useful service provided by the ISPs is that they can host or they can arrange news groups. News groups are also called bulletin boards or discussion boards. This concept means that there would be a certain website, a discussion board hosted by the ISPs, where certain subscribers, certain users, they can go and they can then have some discussion, some debate over different topics. For example, there can be a discussion board about the disease diabetes. So people, they might reach that discussion board, they can get information regarding diabetes through that discussion board. They can provide their comments, their input regarding this topic through this discussion board. And this can serve as a news group where people can exchange ideas, they can usefully contact each other, communicate with each other. Then the files can be transferred using ISP's services. You know about FTP protocol, file transfer protocol, using which files can be uploaded from a local machine to a remote machine, and from a remote machine they can be uploaded to a local machine. That file transfer service can therefore also be, we can say, provided by the or with the help of the ISPs. Here I want to highlight a very important thing, that ISPs, they also operate in a hierarchical fashion. In other words, there will be an ISP at the top, and below that parent ISP, there can be another ISP. Below that, there further can be an ISP, and then there can be a user sitting on the network arranged by the ISP. The ISP that connects to the internet backbone is called the IAP, or Internet Access Provider. An IAP, in order to gain access at the internet backbone, has to make some payment to the internet society, and only thereby it can have connection, it can have access over the internet backbone. The question is, what is an internet backbone? Internet backbone, in simple terms, can be defined as those main internet trunk lines which pass through various major cities of the world. So there is a major internet backbone or trunk line passing through Washington DC, another from Chicago, another from Singapore, etc. A major trunk line passing through a metropolitan city is also called as MAE, or Metropolitan Area Ethernet. On these different MAEs, or Metropolitan Area Ethernets, there are certain connection points. We call them NAPs, or Network Access Points. NAP is defined as that public exchange facility, or those points which are marked on the MAEs, and on these points the IAPs, they are connected with the internet backbone. Now, the routing takes place on these internet backbone lines. It has to be kept in mind that routing in its true sense would take place on the internet backbone line alone. And this is the slide before you which explains the concept. Let me explain that. You can see at the bottom there is a client machine, and it has got services from an ISP. This ISP has got link with an IAP, that is IAP1. This IAP1 is directly connected with the internet backbone line, or MAE, at a point called NAP. This client machine wants to send some information, some data to another web server machine which is hosted by an ISP, and that ISP has a parent IAP which is IAP3 connected to another MAE. Now, the client would send its data packets to its ISP's router. The ISP router would do a passive job. It would simply transmit or forward these data packets to IAP1. This IAP1 now has got its router, the default gateway, which would consult its table and would find out as to what is the shortest possible path through which these packets are to be routed. Assuming that it finds out that these data packets can efficiently be delivered if they are handed over or forwarded to IAP2, another internet access provider sitting on the same MAE. So these packets would be therefore forwarded to IAP2. Then IAP2 would find that they are to be delivered to IAP3. So they are to be routed, they are to be passed over to the router of IAP3 on another MAE. Precisely then that is done. IAP3, the router, then picks up these data packets, then it forwards them to its ISP which is working underneath the IAP3, and then that ISP's router would deliver these packets inserting MAC address of the web server on these packets to the web server. So this is how we can understand in simple terms that data packets, they are routed on the internet backbone. In fact, so far we have been looking at a jigsaw puzzle. Now, at this juncture, we are in a position to understand this jigsaw puzzle and to have a comprehensive understanding of the working of the internet. You can see the slide before you. There is a client machine A sitting on B type of network whose number is 140.57. By now you should have a fair understanding of IP addressing. Please refresh your concept of IP addressing at this step. This client machine A wants to send data to a web server machine B sitting on A type network number 100. First of all, when the client machine types the URL http://ecom.cs.vu.edu for that matter and press enter, in a fraction of seconds with the help of domain name system, this domain name would be translated into the IP address of the server machine where this web page is hosted. So the first step is that through DNS, this domain name would be translated into the IP address. I may point out that if you do not type HTTP, still it would be fine. The browser by default puts HTTP. Now, once this IP address is available with the client machine A, then the data information within the client computer machine A would pass through the TCP IP stack or internet layers. So therefore, you may recall that OSI model and the mapping of that OSI model with the internet model, and you should understand that at the layer equivalent to OSI's transport layer, then the data would be converted into packets. Then in the subsequent layer, the two IP addresses would be placed on the header with the help of IP protocol, means that the IP address of the machine A, which would be supplied to it through DHCP server hosted by the ISP, that would be placed on the header. Besides, the IP address of the web server, which was just received through DNS, that would also be inserted on the header. And afterwards, this information packet would reach the R1, the router of this subnet 140.57. R1 consults its table, and it finds that in this simple example, the shortest path is that it should deliver this data packet to R2 and then it would be delivered to server machine B. Accordingly, the data packets, they are delivered to R2. R2 is the default gateway of network 100. R2 then requests the network server of network number 100 to provide it the MAC address of server machine B. Accordingly, it receives the MAC address, it inserts this MAC address on the data packet and delivers these packets to web server machine B. Now, picking up this data packet, the web server machine would take this data up the TCP IP stack. So therefore, at the application layer, for example, the web server would find out that a particular web page request has been made to it. Accordingly, it would dig out, it would retrieve that web page, that web file from its hard disk, and then it would move this file through the TCP IP stack, and it would move down the TCP IP stack inside the web server B would be converted into data packets. The IP addresses would be placed, the IP address of the destination. Now the destination is client machine A, to which these packets are to be forwarded. Therefore, these data packets from web server, they are delivered to R2. R2 then sends them to R1. R1 is now the destination router. It would ask the network server on network number 14057 to provide it the MAC address of client machine A. Finding that MAC address, it would insert that MAC on the data packets, and they are delivered, forwarded to client machine A's MAC address. Remember that the data packets supplied by the server to the client, they are numbered at the server side, but it is not necessary that they reach the client machine in the same order. The order of receipt of these packets at client machine A may be different, but at client machine A, when they arrive, they are reassembled and then they are displayed, they are downloaded by the client machine A on its screen. So here you see in this particular example, we are in a position to understand comprehensively how the internet works. We may revise this concept of working of internet a little bit in our subsequent lecture. For the time being, we conclude our lecture for today. Until then, Allah Hafiz.